Let's solve a system of linear equations together. Hi, and welcome to Algebra Examples. My name is Dr. Finch. I have a PhD in mathematics and over 20 years of experience in math education. Today we're looking at an example where we're solving by substitution. We have a system of linear equations. Before we even get into this, I just want to point out a reminder that there are three possible outcomes when we're dealing with a system like this. Now, one of the outcomes might be that you get one solution, an x comma y. Those are kind of nice, where x is equal to a single number, y is equal to a single number. All of that is beautiful. You also might get no solution. It is possible to have two lines that never actually cross. So in that case, you'd have no solution. The last one that you might get is infinite solutions. This is when they are technically the same line, and that means that everything is a solution for there. If you take an x value, it's going to have a specific y value. These two functions are the same function. All right, getting into the problem for today, we're going to use substitution. So we are going to pick a equation, it doesn't matter which one, and we're going to work with that one to solve for a particular variable. I'm going to start with the first one because it has just a single y in there, which makes it a little bit easier to solve. So we have negative 3x plus y is equal to 2. And I want to solve for y because it's less work. Anytime you have to do less work, go for it. It's kind of nice in math sometimes. All right, so we have y is equal to 2 plus 3x. When we do a substitution, we are going to then take that information and we are going to plug it in to our second equation. So in this case, we have y is equal to all that stuff, and we are going to plug that in everywhere we see the y, or the one place we see the y, I should say. And don't forget, parentheses are your friend. Put that in. In particular, we want to remember our parentheses because this negative 4 is going to distribute. If you do not do that, things that are bad will happen. So we don't like bad things happening in our math world. We like nice things to happen. So we want to distribute that. Notice we've got a 12x that's positive and a 12x that's negative. Those two are going to cancel each other out. And we end up with, oh dear, negative 8 is equal to negative 8. Now, at this point, you might be wondering, did I take a wrong turn somewhere? We have a statement that's always true no matter what. Well, we did not, in fact, take a wrong turn. What happened in this situation is that we are in the third of our outcomes. When you have a statement that is always true, you are looking at infinitely many solutions for your system of equations. So, it's always true. There are two things that you might write as a solution there. You might say there are infinite solutions, which your teacher will appreciate, but they might ask you for a specific word to describe this system of equations as well. Unfortunately, I will tell you this in a linear algebra class are the only times that you will actually use this word. I take that back. Differential equations as well if you get into that. But if this is the only algebra class and then you stop taking this, you only need to know it for the actual class, and then you can erase it from your mind because you have better things to do. So we might also call it a dependent system. So this one is called dependent when there are infinitely many solutions. I hope you learned something and had fun. If so, please hit like so that other people can find this video. And if you have a question you'd like to see answered, please send it to purplefinchmath@gmail.com.